All right, hello, good afternoon, guys. So first of all, I would like to apologize for us not having classes today, because of the weather. Although it's not none of our fault. Yeah, I'd like to apologize for that first off. Okay, so basically today, what we're going to do is I had planned to go over trigonometry with y'all. I realized that you'll did a bit of trig, well, the beginning of trig with Miss Chico, and basically we'll just finish it off. So, as a prerequisite, guys, we need to go over Pythagoras' theorem. Okay, so we'll just go over Pythagoras' theorem really quick, just so we could begin. Okay, so Pythagoras' theorem. Alright, I want to make the video as short as possible, so I won't be writing that much. Alright, Pythagoras' theorem. So Pythagoras' theorem states in a right angle the square the square of the hypotenuse is equal to the sum of the square of the other two sides. So that's the square of A plus B. Okay, you'll remember that from Miss Chico. All right, so for example, if we were to have a triangle, a right angle triangle, if we were to have a right angle triangle with, let's say, the height of 5 centimeters and a base of 12 centimeters, sorry, what would be the hypotenuse? What would be the hypotenuse? Remember, the hypotenuse is the longest side of the triangle, or it's directly opposite. Directly opposite. Sorry, let me just use another color. Directly opposite to the right angle. All right. So we were given this, and let's say we were asked to find the hypotenuse. How would we find it? All right, so we know that this is the formula to find Pythagoras' theorem, so we could just substitute. So y squared is equal to 5 squared plus 12 squared. Okay, you could go ahead and resimplify that. 5 times 5 is 25 plus 144, and that would give us 144 plus 25 would give us 169, and y to the power of 2. We would like to get rid of the 2, so remember we have to square the y. Whatever we do on the left side of the equation, we also have to do it on the right side of the equation. I hope that my camera is working really good. All right, and everybody could see that. I don't have my calculator right now. I could have sworn that I brought my calculator, but I left it in school, and that would just give us the answer of 13 centimeters. Okay, so here would be 13 centimeters. Okay, all right. So given the knowledge of Pythagoras' theorem, this will give us an introduction into our next topic. So I think that everybody remembers Pythagoras' theorem. If you don't remember it or have some difficulty remembering, you could shoot me a text on WhatsApp or in the Google Classroom group, and I will assist. All right. So given that everybody have a general idea of Pythagoras' theorem, it will help us in our next topic under trigonometry, which is actually the trig ratios. Now, in speaking about the trig ratios, first we need to know how to label our right angle triangle under the given topic of trig ratios. So this is basically what we're going to do right now. Okay, so I'm going to draw a triangle, and we're just going to label out this triangle. All right, so let's say I have a right angle triangle here. Guys, I'm using one hand and multitasking. I have a whole lot of stuff around me. All right, I'm using one hand, so sorry if it doesn't come out that good. All right, so I'm given a right angle triangle with my right angle here. All right, and under my topic, first we need to learn how to label our triangle. So we know that the longest side of the triangle is the hypotenuse. All right, so the longest side of the triangle is the hypotenuse. Sorry. For short, we could just put HYP, and we know that the hypotenuse is directly opposite the right angle. It's directly opposite the right angle. And so far, the other two sides, we could just say we have the other two sides because we don't know what the other two sides are. All right, we're missing a crucial thing inside here, which would say what the other two sides are, and this is our angle theta. Our angle theta. Theta is drawn. Theta is drawn like an O with a little thing inside of it, with a little dash inside of it. All right, so theta represents an unknown angle. All right, and this theta will basically determine what our other two sides are. So in trigonometry, under the trig ratios that we are about to do, we're going to label right now in relations to theta. So the side which is directly opposite to theta, guess what it is? It's the opposite side. All right, it's considered the opposite side. So the side directly opposite to theta is the opposite side. It's the opposite side. But for short, we'll just put opposite. All right, so this side is opposite. For short, we'll just put OPP. All right, it'll come into handy in a while. All right, and the side which is directly next to theta, is considered the adjacent side. Okay, we know that adjacent basically means next to. All right, the adjacent side. All right, for short in mathematics, we just put ADJ. Okay, so now we know how to label our triangle in trigonometry. All right, so I paused the video so I could have drawn on another page on what I wanted to do. Hold on. All right, so as you could see, I drew a right angle triangle and I labeled my triangle in reference to theta. So as you could see, directly opposite theta is the opposite side. Directly opposite to the right angle is the hypotenuse, and adjacent to theta is the adjacent side. Now what I did is I measured my triangle, and these are the values that I got. They're not exactly accurate, but these are the angles, these are the lengths that I got. And I also measured the angle of theta. I measured the angle of theta and I got roughly 40 degrees. You can't see it properly, sorry about that. I got roughly 40 degrees. All right, so these are the values that I got. So what I've noticed is, guys, and this really helped me in school, is that if I were to take these values and put it against these ratios, opposite over adjacent, adjacent over hypotenuse, and opposite over hypotenuse, I would get these values. Don't laugh about my piece of paper. I just took a piece of paper so I could explain. I would get these values. Now we're coming to the awesome part right now. What I noticed is in school, is that I drew two identical triangles. All right. Well, one is a large triangle and one is a small triangle. If I were to take a pencil or I were to take a scissors and I were to cut this triangle going down this way like this, making each side shorter, all right, I would notice that though each side of my triangle got shorter, or my angle remained the same, you would see that if I were to take those very same values, although each side got smaller and my angle remained 40 degrees, approximately 40 degrees, you'd realize that if I were to take those numbers, all right, I'm just going to write it up here in red. So the value of the sides of the smaller triangle, hypotenuse 12, opposite is 7.5, and the adjacent is 10. You'd realize that with this angle remaining at 40, although the three sides got smaller, if I were to take those very same numbers and put it against those ratios, you would find that I would get the same answers. All right, so what this basically made me realize that when I was writing CXC myself is it doesn't matter what size the triangle is, all right, whenever the angle is the same, whenever the angle is the same, you get similar ratios. All right, guys, and this basically brings us to our trig ratios. All right, so our first trig ratio, I'm going to pause the video to save time to just write it down, is the trig ratios are sine, cosine, and tangent. All right, I'm going to pause the video. All right, not sure where I left off because basically somebody called me and the video paused. Sorry about that again. All right, but like I was saying, this basically brought us to our three trig ratios, which is sine, cosine, tangent. All right, so to find sine, it's basically the opposite side over the hypotenuse, just like how we have up here. The opposite side over the hypotenuse. To find cosine, it's the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent. And remember, guys, you basically label the sides in reference to the theta. All right, in reference to theta, you basically label the side. So directly opposite to theta would be the opposite side. All right. Opposite to the right angle is the hypotenuse, which is the longest side in the triangle, and adjacent to theta is the adjacent side over here. All right, and the acronym we normally use in mathematics to help us remember the three trig ratios are SOHCAHTOA. All right, so the first letter S basically says sine, and the other two letters basically tell us in what order the ratios come. Okay, so OH basically opposite over hypotenuse, like they said there. Cosine is adjacent over the hypotenuse, and tangent is the opposite over the adjacent. All right, guys, and these honestly come in clutch. All right, these honestly come in clutch during exams. Okay, so just try to remember this. All right, SOHCAHTOA. The video is already at 11 minutes right now, so most likely I'll just be sending this video on OneDrive and just forward you the link. So you could just basically look it up. At the end of the session, we basically have some assignments to do, and I also have 3 CXC style papers for you all to do, three CXC questions so that you could do. All right, just one. All right, guys, now take into account this example I have in front of me. All right, this is like just a simple example. So our example says find the sine of this triangle. All right, well, they have already told us which trig ratio to use. All right, so they told us to find the sine of this triangle. Okay, so we know that this is sine by knowing the sides that we have available. So directly opposite to the triangle, directly opposite to theta, is 2 centimeters, and directly opposite the right angle is the hypotenuse. And we know from our acronym, so, all right, sine is basically the opposite over the hypotenuse. All right, so let's just go ahead and just find just a simple question, the sine of this triangle. All right, so the sine of this unknown angle theta would be equal to the opposite over the hypotenuse. All right, which would also be equal to, all right, let's say, which would also be equal to, the opposite is 2 centimeters. Remember, this is the opposite over there. So the opposite is 2 centimeters over the hypotenuse, which is 10 centimeters. All right, which would give us sine of theta, it should be 0.2. All right, so the ratio between the opposite side and the hypotenuse is 0.2. All right, so sine of this angle equals 0.2. Sorry, guys. And basically, this is the example of how we find sine of a triangle. All right, so we just find sine of a triangle, but we could also use this. We could also use this trig ratio to find the length of missing sides inside of a triangle, just like Pythagoras' theorem. So let's say we have this triangle as example, okay? Let's say we have this triangle as example, okay? So we have an angle, we have the hypotenuse, and we're missing the opposite side. So we know that there are two sides they give us, all right? They give us the unknown side, which is the opposite, because it's directly opposite to the angle theta. And we know that this is the hypotenuse, because it's directly opposite to the hypotenuse, okay? So we're basically going to go about by solving for this, okay? So finding find it, missing side. Missing side. All right, so we know that the sine, we know that sine of theta is equal to the opposite over the hypotenuse. All right, and we could basically just transpose the different elements we have there for the actual values, okay? So let's just do a little bit of transposing. All right, so we have sine of the angle is 53 degrees, all right, 53 degrees is equal to the opposite side. Do we have the opposite side, guys? No, we don't have the opposite side, okay? So we'll just leave it as x over the hypotenuse, which is directly opposite the right angle, or 30 centimeters. Okay, all right, so we basically were required to solve for x, and this is like a typical question you'd get on CX, you guys. This is like a typical question. All right, and that's pretty much very simple to solve, guys. What you'd be required to do is to transpose, guys, and make x the subject. All right, but most times what we have already observed in the math community that sometimes it may be difficult for students to transpose. So what you could do with the general idea or the general knowledge of equivalent fractions, guys, with the general knowledge of equivalent fractions, we could make transposing and finding value for x pretty simple by cross multiplying. I'll basically show what I mean in a while. Okay, so we're just going to cross multiply. Okay, we're going to cross multiply the sides to make x the subject. All right, so 1 times x is x. All right, guys, and sine 53 will be multiplied by 30 centimeters, sorry. All right, and we could go ahead and basically solve this, guys, by using our calculator. All right, we need our calculator to find this. I take it that everybody knows the sine key on the calculator. If you don't know, I will basically show. Sorry about me not having my calculator. Okay, sorry about me not having my calculator. I end up forgetting it at school, and yeah, I'm home right now. So this is the sine key right here. All right, and the way we'd basically go by solving this is first pressing the sine key. Sorry, and putting in our degrees, which is our bearings, which is 53 degrees, and then we're going to multiply that by, sorry about that. All right, then we're going to multiply that by 30 degrees, by 30 centimeters, sorry. Let me see if I got this answer correct. All right, and basically we'll end up with a decimal. All right, but we're just going to round it off. Okay, so we got this decimal 23.95. All right, but we're just going to round it off to keep it as a whole number. We'll just have it as 24 centimeters. All right, we're just going to round it off and put it as 24 centimeters. But mostly, guys, in trigonometry, we normally bring our answers to 1 decimal place or to 3 significant figures. All right, and for those who are wondering what I was saying about the equivalent fraction, we could basically use the concept of equivalent fractions to solve for missing value. All right, so y'all could remember equivalent fractions are basically fractions with different denominators and numerators, but they have the same value. Just like 1/2 is the same as 2/4. Hold on, sorry. All right, sorry about that. So I was saying 1/2 is the same as 2/4. There are some people in the background speaking. Okay, the same could be said, let's say if I were to have 2/5 is equal to 10 over x. Okay, we could basically go ahead and solve for x by cross multiplying. All right, we already know the answer. We already know that 2 into 10 is 5, so we basically just have to multiply the bottom by 5 to get the answer here, which is 25. So just have that in mind. It's 25 you're supposed to get. In some cases, such as this here, when we transpose in and we have an equal sign in the middle, or currency as well, this would come into play, changing from one currency to another. We could basically cross multiply. Okay, so we multiply the top number by the bottom here, and we do that diagonally. Okay, so 2 times x is equal to 5 times 10. We could go ahead and simplify. 2x will give you 5 times that is 50. We want to get rid of 2, so we divide it. We divide this side by 2. Whatever we do on the left, we have to do it on the right. Divide this side by 2. Cancel out. We have 2 into 2, 1. 2 into 50, 25. Okay, so you see that we got 25 here. All right, guys, and this would come into clutch a lot of times, especially for CXC, guys. If you want to save time, okay, you could use the concept of equivalent fractions to cross multiply when you have equal values or when you have an equal sign in between. Okay, let's go to our other example. Let me just pause the video to save time. All right, so another example is we're given a triangle, okay? We're given a triangle, and we're required to find the length of y, okay? And we could use the trig ratios again to find the length of a missing side, like I said a while ago. Okay, so we're given the angle, which is 48 degrees. We're given the one side, which is 10 centimeters, and the other side, which is y. It's unknown. All right, so straight off the bat, we could see that over here is our opposite side. We have nothing to do with that because they didn't access anything about that. We see we're given the adjacent side because it's directly adjacent to the angle, and we could see our right angle over here, and we know anything which is directly opposite the right angle is the hypotenuse. All right, so we could just go ahead and label it. All right, hypotenuse, and we have the adjacent. Okay, and we could look for which trig rule that encompasses both the hypotenuse and the adjacent. Let's just go back. All right, so I could see hypotenuse and the adjacent. I could see that this is cosine. All right, ka encompasses our adjacent over our hypotenuse. All right, so what we're trying to look for, our hypotenuse, so we could go ahead and solve for it. So I'm just going to put my acronym up here, which is ka. All right, and I'm going to write out my statement. Mr. Jude is your teacher. You all know that Mr. Jude is adamant about our statements. Even now, whenever I teach, I always tell my students, write your statements. All right, so if you get lost or if you forget what you're solving for, you could always go over your statement and see what your session is for. So finding length of y. All right, finding length of y, we could probably add in there using cosine. Okay, so we know that cosine is equal to the adjacent over the hypotenuse. All right, so we could basically transpose this equation for our actual values, which is cosine of 48 degrees is equal to the adjacent, which is 10 centimeters over the hypotenuse, which is y. All right, which is y. So we're trying to make y the subject here. We're trying to make y the subject. All right, guys. If we want, we could go ahead and cross multiply. Let's just do that cross multiplying real quick, because honestly it comes into clutch because some students would get confused over here. Normally what I would do is to just switch the y with the cosine, but some students might not know why you do that. All right, but the cross multiplying comes into clutch, guys. It comes into clutch. Okay, so 1 times 10 is 10 centimeters is equal to cosine 48. Cosine 48, we want this in brackets, guys, because we don't want to mix it up with the y. Cosine 48 multiplied by y. Sorry. All right, so remember we want to make y the subject. All right, what's preventing y from being by itself? The cosine. All right, so the cosine is multiplying y, so basically we divide. Okay, so we divide by cosine 48, and whatever we do on the right side, we do it on the left side. And guys, if this is not as clear, remember you could always shoot me a text. I could help you with the assignment. And when we get back in class next Monday or Saturday, if we have remedial classes online, I could always help you out, guys. I know online poses some challenges where it creates a barrier between the two of us. Okay, but I'm here to help, so whatever it is, guys, I am always willing. So we could rewrite this expression to y is equal to 10 over cosine 48. All right, so I could use my makeshift calculator over here. Please don't laugh at my calculator. All right. All right, so it was basically 10, 10 divided by open bracket cosine 48. Cosine 48. All right, and that would be equal to 14.948. So y would be equal to 14.944. We could go ahead and simplify this. Put it, just round it off to 15 centimeters. Okay, so that's 15 centimeters. All right, and basically this was the solution to it. So y is 15 centimeters. All right, guys, so on my book right now is basically a typical example of a CXC type question. So as you could see, I have one, we could just say isosceles triangle because I doubt it's equilateral. I doubt all sides are equal. I personally cannot draw, so it came out rough. All right, so we have a triangle and we could see that there is a line cutting our triangle in two, and you could see two right angle triangles inside of there. All right, so you could see on the left side I have the hypotenuse as the square of 2 centimeters, the height as x, and the base as 1. And onto the other side of my triangle, you could see I have the hypotenuse as y and the angle as 60 degrees. All right, guys. And basically, this is an example of a CXC type question. You could see that the square root of 2, most of you will be freaking out right now. Yeah, but it's just something to throw you all off, okay? So we're required to find the value of x and find the value of y, okay? Now, you could see in this example over there, we're not given an angle, but you could see we're given the value of two sides and there is a third side. That should probably ring a bell in your head right now and be like, ooh, that sounds a lot like Pythagoras' theorem, where the length of the hypotenuse squared is equal to the sum of x and 1 squared. Okay, so the first side of our problem, when we find in x, we basically have to conduct Pythagoras' theorem. Okay, I'm just going to do it really quick. I'm going to pause the video because it's already at 27 minutes. I'm just going to solve it. Okay, and I'm just going to read through it really quick for you afterwards. Yeah, and then we're just going to take it from there. Alright, guys, so finding the value of x using Pythagoras' theorem, we know that x is over here. Guys, I could just pause the video and basically just draw it so you could keep up. Okay, and we know Pythagoras' theorem is c squared is equal to a squared plus b squared. Okay, the value of c, the hypotenuse, was the square root of 2. Now, we know we're supposed to square that. And we know whenever a square root and a square comes together, they're basically the opposite of each other, so they just cancel out. Okay, a was the value of x, so x squared plus b, which is the base, is 1, so we squared a 1, sorry. Okay, we could further simplify this. I basically just switched this x over to that side of the equation, and I brought my 2 onto the other side of the equation to just basically make it easier to deal with the constants and then the variable. So 2 subtract 1 would give me 1. All right, it was basically squared, so I basically found the square root of the two of them. Okay, the square root of 1 is 1, the square root of x squared, basically the 2, and the square root would basically cancel out. Okay, so now we could see the value of x over here is 1. Okay, so the value of x over here is 1, and given this value we could go ahead and solve for the rest. Okay, now they told us to find the value of y. All right, we could see that directly opposite, we have the opposite side, and y is basically the hypotenuse, so the trig ratio we'll be using is the opposite over the hypotenuse, which is sine. Okay, we'll be using sine. All right, so when I found the value of y, all right, so we established that we're going to use sine, and we know sine is the opposite over the hypotenuse. All right, so the sine of 60, when we basically transpose for the actual values, the opposite side is 1, the hypotenuse is y. Okay, I basically put this sine 60 over 1 to allow us to cross multiply. Remember when I was talking about the cross multiplying, it makes it really easy to transpose. Okay, so y times 60, all right, y times 60, and 1 times 1, all right, and the equal sign is in between. Okay, now the reason I put the sign 60 underneath is because I want to get y by itself, okay? So remember when we want to get y by itself, we basically remove what's preventing y from being itself by itself, which is sin 60. It's multiplying y, so we have to do the opposite, which is divide. So we divide by sin 60, whatever we do on the right, we do on the left, okay? Then I get 1 over sin 60 is equal to y, as you see there. All right, and when I use my calculator and I put 1 divided by bracket sin 60, I got 1.15 centimeters, okay? So the length of y is 1.15 centimeters. And guys, it's okay if you're confused, because I know trigonometry can be a real issue, and after all, it's online, and me creating a video from the scratch of trig to all the way to finding a missing side. Some of y'all might pick it up, some of y'all might find it challenging, but hey, remember, whenever we go into class, or if you have an issue, you can always shoot me a text, and I'm always willing to help you out. Okay. One more thing I want to show you before I end the video is the inverse of sine. Okay, so let's look at this first example here. All right, so we have sine x is equal to 0.707. All right, so this 0.707